Hi, my name is Sarashik, and my topic is reconstruction of a continuous time signal from samples. So, why do we need sampling? Computers cannot work with continuous signals, so we have to discretize. And one sort of such discretization is impulse train sampling. Um, and this is shown here. Suppose we have a signal x of t. We'll take an impulse train p of t with period t, and we'll multiply them both. And what we get is xp of t, which is basically just scaled impulses at evenly spaced intervals with period t. So on the top, we have our signal x of t in the frequency domain. It's a band-limited signal with Wm with the maximum frequency. And if we multiply by an impulse train, it's basically convolution by an impulse train in the frequency domain. This results in replication of our frequency response at integer multiples of the sampling frequency, as shown below. And we must note that aliasing will occur if the sample frequency is not greater than twice the max frequency. So we can reconstruct original signal x of t with an ideal low-pass filter and gain t. We take xp of t to do that. And in the time domain, the low-pass filter impulse response looks something as below as a sig function, and in practice, it's very hard to generate something that looks like this. In practice, it's very hard to represent a signal as an impulse train, so a better way is to hold the signal value until the next sample, and this is called a zero-order hold. This is akin to impulse train sampling followed by a convolution by a zero-order hold filter with an impulse response shown in the right image, h naught, and this results in our signal x naught. So convolution with a zero-order filter results in distortion of our frequency content, as seen in the image on the left. So what we have to do is pass it through a low-pass filter while inverting the distortion that we see, so we get a reconstruction filter that we see on the right image.